Okay, so let me just read the definition for you first. That FOS be defined on an open interval about x0. So I believe you know that, right? On Monday, I already told you that the open interval will include x0. But based on statement here, based on this definition just requests fx should be defined on this open interval, maybe possibly including x0 or not including x0. But for x0 itself, for others, for fs, it must be defined for other points except for x0 itself. So this is a basic requirement. Then if the fs just meet the following situation, then we will say limit x is approaching x0, fs will be L. So for any epsilon, for any given epsilon, so that means here, or maybe I should use, so maybe just let me just rewrite this part here, because so that we can keep the slides here, and then you can keep it today, even though later. So based on the definition here, that FOX be defined on an open interval containing x0 itself, but it may possibly except for x0 itself, possibly. So I remember last time I just explained why they always emphasize this part, because when we want to get the value of the limit at some certain point, at that point it is not always necessary for us to have the definition for that point, right? So they always add this sentence there to describe the situation. So if for every number epsilon, there exists a delta such that for all x, where the distance between s, when we just take the absolute value between 2 points, that means we just try to measure its distance, right? So if the length is less than delta, then you always can get FOS. The distance between FOS and L is less than epsilon. Then we will say the limit s is approaching s0, FOS is L. So you can see, based on the definition, which is very, very different from the previous one. In the previous one, we just say, oh, for the x should be very absolutely close to s0. Then FOS, the value of FOS will be very, very close to L. Did you remember that? In the previous section, we just talked about this. When we just define what is the limit, we just follow this way to define what is the limit. Then we also use this one. When the FOS value will be very close to L, when x is sufficiently close to x0. So here, based on this definition, we can find the definition is very rough, not that clear. But actually, these two statements also want to describe the same thing. What is the same thing? They just want to describe limit x is approaching x0, f of x should be L. So maybe for you, because the definition here is very abstract, 非常的抽象. So I will suggest my student, please just try to explain this into S should be between S0 plus delta and S0 plus this is subtract delta, then S should be in between S0 minus delta and S plus delta. Also, you can just explain this into f of s. We will sit between L plus epsilon and L minus epsilon. So let me just draw a picture for you, then so that you can know that. What is the idea? What is the precise? What is the operation for this? So you can see here, for any epsilon, positive epsilon, that means I will give you an epsilon. This epsilon is given. But based on the epsilon, I always can return a delta. So you can just look like, you can just regard epsilon and delta could be a pair. You know, when I give you an epsilon, for example, 1, then I will return a delta like 0.5. If I give you epsilon is 0.5, then I will return delta should be 0.2. Something like that is a corresponding relationship. So I give you this one, just like you play tennis or table tennis, you know, when I hit the ball to you and then you will hit it back to me, right? So you can look at like challenge and response. When you try to log in some system, the system will prompt, please just input your username and password, right? When you just input your username and password, then the system will return the authentication result back to you, right? For example, if you don't remember your username or you forgot your password, you cannot get through a system. The system will respond, okay, you may be a illegal user. But once your username and password are correct, then you can pass through, right? So it's kind of challenge and response. CHANGE. Okay, it's a challenge and response. I challenge you. You are not a legal user. So you need to type in the username and password. If correct, I will let you pass. So it's a challenge and response. Okay? So please just make sure you know these two variables role first. Then, okay, so what is the result? That is just talking about it. For example, this is y is equal to f of s. If we say s0 here, if we say limit s is approaching s0, f of s will be L. That means when you give me a epsilon, then based on L, we can just have a range. We can get a range from L minus epsilon to L plus epsilon. Then once I get this one, I always, here is given, right? Then I always return some delta. Using the delta, you can define S0 minus delta to S0 plus delta. Then all of x, if x is located in this subinterval, you always can make sure its function value will sit between L minus epsilon to L plus epsilon. No matter the epsilon, how small the epsilon is. For example, taking this as an example, you can see if the epsilon is maybe 0.5, then you can just use L as a center. Then you can just have a range between L minus 0.5 to L plus 0.5. Then I always can return one delta. I already give you epsilon, so I can give you a delta like delta 0.5. Then using S0 as a center point, if the range is from S0 minus delta 0.5 to S0 plus delta 0.5, then all points here, when you just using them as the input for the function, you can see they will fall into this subinterval. So I give you, when epsilon is 0.5, you can find the delta. So again, if I just make the delta become smaller, like 0.01, so that means still through this curve, this time L is still there, but epsilon has been changed to 0.01. So you can see the range will become small. It will become L minus 0.01. This is L plus 0.01. So you can see, compare here and also here, you can see the domain is much smaller than this one. So that even though the epsilon is become smaller, I still can return another delta. It could be for 0.01. Then you can see we just form a range from S0 minus delta 0.01 to S0 plus delta 0.1. So all points here, when you just use this point as an input for the function, you still can find it will still fall into this range. So even you can just set epsilon could be very small, very small. Okay, so again, this is L, but this time, since the delta is epsilon is very small, so maybe the range is still very small, using L as a center. But even so, I still can return a delta. So the delta here is for 0.00 blah 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 1. But this time I still use S0 as a center point. When you use S0 minus delta 0.0 blah 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 1 to S0 plus delta 0. Blah 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 1, then all point here when you just use it as a input for the function, it will still fall into the very small range. So you can see when we just describe, so this idea is just trying to tell you what close is. What close is. So you can see when we just describe like this one, it's very descriptive way to say close. It's a descriptive way to describe about the close. But if we just use the very mathematical way, it would be like this one. So even though you give any positive epsilon, I always can find a return delta to let the situation happen. Then we will say, okay, limit x is a positive x0, f of x is L. I know this is really hard for you if it's just your first time to understand that, but this is also very important for calculus because limit is a very fundamental concept for differentiation, for integration. So, but how to describe the close property? We can just use the precise definition here. 我这边用中文稍微讲一下，这个来讲是非常对大家来讲应该是相对的是非常抽象的但是这个抽象的定义，你等你了解到它的时候，你会发现它其实又非常的漂亮，甚至是一个非常美丽的描述。描述什么呢？描述所谓接近这件事情。我们在第二节的时候讲过什么叫做几极限，对不对？它只是很粗略的讲说，任何 x 只要足够靠近 x0 的时候呢，它的函数值 f(x) 呢要必须随意的靠近这 L 值。所以这里其实已经让我们有一个就是说有一个所谓接近的概念了，对不对？就是你只要 x 的值呢很接近 x0 呢，你把它放进去的值呢会很接近 L。但是至于这个接近，你们觉得他讲的有点含糊，有点就是说不是那么那个感觉，好像是自由新政那种感觉。但是2之3用这 precise definition 就写得非常的漂亮。漂亮在哪里呢？它是用epsilon跟 delta 的概念来做所谓的接近的概念。它必须要满足什么呢？这边可能要请大家多看几次，你才会接受这种概念就是对所有的 x， 对所有大家注意到 x 是什么？自变数f of x 是因着 x 而决定的函数值，对不对？记不记得我们第一天上的 x 是自变，是可以自己决定要放什么，只要在它的 domain 里面，它 return 的值是 f of x， 对不对？所以呢，它的意思是说，如果我呢给你个 epsilon， 这 epsilon 是在值域的范畴里面在这个值域的范畴里面呢，我一旦给你一个框起来的这个范围，用 epsilon 来框，怎么框呢？以 L 当中心，正负 epsilon 当半径，这样的范围呢，我呢一定可以找到一个 delta 对应的 delta。我给你一个 challenge， 你给我一个 response， 我一定可以找到一个 delta， 找到一个 delta 代表什么？意思是说它可能有好幾個 delta， 但是你起碼你一定會找到一個 delta。這個 delta 滿足什麼呢？當你的 x 定義這邊的點，對不對？你的 x 減掉 S0 的絕對值小於 delta。一開始大家看這個不習慣，我會勸大家把它展開成這個樣子。這個不等式大家知道它展開出來是這樣子，對吧？ 这个具有绝对值的不等式嘛，把它展开出来是这个样子。这个意思代表什么 ？x 的范围只要落在 S0 减 delta 跟 S0 加 delta 里面，它所有的函数值，它把它的这些点把这些 x 的点呢带到 FOS 来，它跟 L 的值呢不会超过这个 delta 的距离，不会超过这一雄，不会超过这一雄。所以你再把它展开出来，这个事实上也是对等的，就是说从这个角度来看，就是它的函数值不会超过 L 减一雄跟 L 加一雄的范畴。所以是不是就我所讲的，你给我一个一雄，你给我一个一雄在这里，你给我一雄，我呢永远总是可以回传一个 delta， 这个 delta 也许不是唯一的，但是我可以告诉你有答案，就是某个 delta， 让它以 S0 为中心，正负 delta 范围里面的所有点呢，把它带到函数里面的时候，它的点的值脱离不了这个范畴。大家有没有听过那个什么？当年那个什么这一些神话，就是那个什么孙悟空有没有？他不是被人家压在那个，他不是说他可以一翻跟斗，可以翻什么10万里，对不对？可是他永远逃不出那什么如来佛的手掌心。这里意思就是这样，我空这么大，我一定可以告诉你有一个 delta， 这个 delta 是以 S0 为中心，正负 delta 范围里面的所有的点呢，把它带到这个函数值的时候，你逃离不了我这个范围。好，也许我们拿这个来看，课本画得很漂亮如果你有课本，你可以看一下比方说一开始 delta 只有 0.5， 那我就以 L 为中心，正负 0.5 当一个范围框出来之后，我会告诉你 OK 有一个叫 delta 0.5 的，我一定可以告诉你一定可以告诉你 L0 减 delta 0.5 跟 L0 加 delta 0.5 的范围里面的点带到函数里面，它逃离不了这个范围。好，我紧接着把一雄范围再拉更少一点，变成 0.01， 所以大家比较一下，这 0.01 是不是比这个 0.5 还来得小？我给你的是 0.01， 你也会回传一个叫 delta 0.01 的。这个变数呢，在 S0 为中心，正负它的范围之下的点带进来，还是逃离不出我这个范畴。所以呢，我再来一个更夸张的，这个一雄可能非常小，小到 0.00001， 所以代表什么？你这范围已经非常小了，小到几乎它贴在一起了，对不对？没关系，我在 S 的范围里面呢，我还是可以找出另外一个叫做 delta 0.01的 delta 的值呢，来对付你。对付你什么呢？只要 S 落于这个范畴呢，它永远逃不出我这个手掌心。所以你们发现，它要永远存在这种关系if for every number， 它要经得起考验，就是我给你任何一雄，哪怕它是0.1很大的数字，哪怕它是一雄是非常小，小到0.1万个零、1000个零、1亿个零之后再一个1的这么小的范围，没关系，我永远还是可以告诉你有个 delta。当你的 S 被限制在这个正负 delta 以 S0 为中心正负 delta 范围里面，你的 S 的函数值永远也超脱不了我这个小小的范围。所以大家可以感受到那种 close 的感觉吗？老师讲得很辛苦，你们听得很模糊。但是真的这个这就好像什么？那古文有时候就是那种只可意会不可言传。我尽可能用白话文讲得很清楚，可是你如果是细细品味，你会觉得这是非常漂亮的定义，有没有？我现在尝试言传给你们听嘛，对不对？你们慢慢可以体会到它的漂亮吗？它的 beauty。然后哪一天你觉得哇，这数学真的是这样的讲是很无懈可击。然后就会掉进数学系的不会。不会，放心好了。 但是我觉得我们虽然没办法成为数学家那么的这个那么的投入，但起码这个我觉得真的是非常经典。那因为我们的时间很有限，我告诉大家，我有一个微积分的学生，他去统计过这一雄 delta， 你学完整个微积分，总共你会遇到15次。我相信啊，过个1-2次，你就慢慢接受这个漂亮。真的，哎，我在讲可能只有我一个人在孤芳自赏，哎，真的。但是他真的，我觉得他在描述接近这件事情的时候，真的，你看，就4句话而已哦，就几句话而已哦，好，我会帮大家洗脑，到最后跟我相信它是一样很漂亮的。好 ，OK， so let's just continue. I can just describe the same description as the following mathematical language for any epsilon, positive epsilon. I always can find a delta. Okay, so this is for all. I remember last time I told you, right? This is for all. But this is, I can find the one. So this is not about for eyesight test. You know eyesight test? Here you will say, okay, the open is at the right hand side. This is for the left hand side. This is for the upside, right? No. This is this is the opposite E. Okay. So I hope you can understand these symbols, because later on normally we will use this one to shorten the description for the description. So this is I can find one, but if I write this one, you can see this is a special bar here. This means find the only one. So they are different. Here is, I can say I can find delta. Find one delta. So that means more than one delta could be make it satisfied. Okay? So for any epsilon, positive epsilon, I always can find a positive delta. Such that, this is such that for any x, if x and x0's distance less than delta, then I always can get the distance between FOS and L will be less than epsilon. Then we will say limit S is approaching S0, FOS will be L. So you can see the description here actually is same as this one. So finally, you can see only 4 steps for all epsilon. Let me just emphasize it again. I give you epsilon. Then you can return me a delta. Then if for any x, if x, the distance between x and x0 is less than delta, then I always can get the distance between FOS and L is less than epsilon. Then we can conclude its limit exists at L. Okay, so 4 steps. So let me just tell you that. So you can see when I give you an epsilon, I always can get a return delta. So that means you can see the delta should be related to epsilon, right? We can regard delta as a function of epsilon. Because I give you a different epsilon, maybe I will return different delta to you. right? So we always can see it's just like a pair. It's not just like when I give you epsilon, you can return a delta. So the delta should be related to epsilon. Just like here, I give you a epsilon 0.5, I return a delta for delta 0.5. This is especially for epsilon is 0.5. So I give you epsilon is 0.01. Then I can return another delta 0.01 for you to meet the requirement, right? So that's why I say epsilon and delta could be, you can regard them as a couple, a pair. But again, let me just emphasize that the delta here will not be the only solution. You may have many solutions, but you just pick one of them. You just pick one of them. That is more than enough. Okay? So let me just show you an example that, for example, if we want to show that limit s is approaching 1, 5x minus 3 is, what is the answer? What is the answer? 2, right? But this time, I ask you to, by using the precise definition. So if I ask you to using precise definition, that means you need to prove. In this case, this situation holds. This situation holds. So, okay, let me just show you how to do that. So in this case, let me just write down what we will do is here. For any epsilon, positive epsilon, I always can find a delta. For any x which is located between x minus s0, its distance between s and s0 is less than delta, then I always can make f of s, the distance between f of s and L, less than the epsilon, right? So this, I just write the precise definition here again. I just write down it here again. Then based on this case, we can see, okay, based on this case, students, can you tell me what is x0 here for this case? For this case, what is x0? 1, right? 1. Great. What is f of x? 5x minus 3, right? What is L? 2. Correct. Very nice. Very nice. Okay. So right now we already have this, right? So in the beginning, for epsilon, any epsilon, I can try to find a delta. But at this moment, I don't know what it will be related to epsilon. But I just know this delta should be related to epsilon. But I don't know what's the relations. Okay? Then for any x such that, right? Such that for any x, when the distance between s to s0 here, we already know it should be 1, less than the delta. Then we hope f of x minus L could be less than epsilon, right? But you already know f of here, it should be 5x minus 3. L here should be 2, right? So we expect this statement will hold, right? We will expect. So that means we hope this this relationship could be no problem. So that we can say limit x is 1, 5x minus 3 is 2. Right? So I hope this statement can hold. So based on this, I expect blah 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 here, then this will hold, right? So that means 5x minus 3 minus 2, its absolute value should be less than epsilon, right? We just reverse it from the final result. The final result, we hope it can happen. It can happen, right? So that we hope 5x minus 3 minus 2, when we take its absolute value, it should be less than epsilon. So based on this, we can get 5x minus 5, when we take its absolute value, should be less than epsilon, right? Then 5 times x minus 1 less than epsilon. Then x minus 1 should be less than epsilon 5 over 5. So finally, based on this one, finally we can get this one. So did you see a matching here? This is the absolute value of x minus 1. Here is also, right? Here is also. So if you just try to match them, you can see here, you just match here, right? Because this is 1, right? So it should be s minus 1. Here is s minus 1. Then here is the delta, right? So if we just match it, so that means we just set delta to be epsilon over 5. Then can we just let this happen? So based on this, maybe we possibly take, based on this result, we will choose thus we can take delta could be epsilon over 5. Then right now we have an answer for the relationship between epsilon and delta. So then let's just write it again. For any epsilon, positive epsilon, I can find a delta. This time I already know the delta should be epsilon over 5. Not like here, right? Not like here. At that moment, I didn't know the relationship between delta and epsilon. But right now, based on the result, we can conclude if we just set delta to be epsilon over 5, it could possibly make this statement hold. Okay, so when I give you for any epsilon is positive, this time I already know it is possibly to be epsilon over 5. Then let's just continue. When s minus 1, when we take its absolute value less than the delta here is epsilon over 5, then we can get this one, then we can get this one, then we can see 5s minus 5 taking its accelerator is less than epsilon, then we can continue to make it become 5x minus 3, then minus 2, less than epsilon. Then finally you can see f(x) minus 2 is less than epsilon. So we can see finally this is the first step. I always can find a delta. This time I know delta, what delta is, and especially what delta, what relationship between delta and epsilon we can have. Second one. Then this is the third one. Then finally we can get this one. So you can see this fourth step can totally match the requirement for the precise definition. Right? Then we can conclude, okay, limit s is approaching 1, 5x minus 3 is 2. This is L. Right? So let me just describe again by in Chinese, because you know it's really hard for students when it's your first time to encounter the description for the limit, especially is in precise definition. OK， 大家看一下哈，这个证明哈，如果是这样写这个哈，这太欺负你了哈，这个你应该知道答案是2哈。但很不幸的，他后面叫你要用 precise definition 来证明啊 ，show that 的意思就是证明 ，OK， 好，所以你就不能直接单纯说是，他就是这样啊，就是把1带进去啊，然后5减3就是2啊，那就得正了啊，不是这个哦，不是这样写的，他要用 precise definition 就是要要求你把epsilon delta 的概念放进来，所以如果他是要你用epsilon delta 的时候呢，切记。你就是要完成这四个条件，什么条件呢？对这个epsilon大于0，这是第一步，对不对？我永远可以找到一个 delta， 我永远可以找到 delta。你给我epsilon，我就可以找到一个 delta。你给我另外一个epsilon，我就可以告诉你另外一个 delta。使得什么事情呢？第三件事情，使得这件事情发生的时候，什么发生？发生什么？你要取极限值的那个点 x0， 当你的所有的点你的 x 落在 s0 加 delta 跟 s0 减 delta 之间的时候，也就是这个不等式的时候呢，你的 f(x) 的值必须跟你的 L 的值呢，要落在这个epsilon之下。这个就是我刚刚画的这张图，这就是我刚刚一开始解释的这个epsilon delta关系，这就是我刚刚讲的形容接近这件事情多么漂亮的被数学的式子所描述出来，对不对？所以你要满足这4要件哦。所以这种题目要证明的时候，要满足这4要件，那你要怎么做呢？第一件事情当然不错，大家都跟我一起对得很好。以这个例子来讲 ，x0 应该是1。你的 f(x) 应该是 5x 减3，你的极限值应该是2，你的目标是希望证明这件事情，红色框起来这4件事情是成立的。有这3个条件之下呢，你的式一定要成立。好，那这种证明呢，其实你如果去看一些比较高等的或者比较复杂的式子 ，f(x) 不可能像这种线性的啦，超复杂的。这也是我一开始被微积分打败的地方，也在这里。它非常的难，难在哪里？它的式子，这是为了让大家有信心，所以我们用的是这非常简单，它是线性的嘛 ，5x 减3是一个线性函数，所以基本上你都可以猜出来，这答案是2。可是有时候这个函数，它如果比方说是 sin 的5次方减根号，2次根号 x， 哇，那你就麻烦了哦。通常我们不会考这么难的哦，那会涉及到很多不等式的转换，那个是不是超乎大的范围？但是 起码哈，我们不像数学系要去 dive into 这些 detail， 但是起码我希望大家去痛苦过一次那种一雄 delta 的感觉。如果你学微积分没有被一雄 delta 折腾过，那就不叫真的学过微积分。所以这一段真的要把它搞懂，虽然考试是真的很难考，但是我觉得大家一定要把它搞懂。好，回归正题，就是我的目标要让这4件事情满足。所以呢，它的做法是这样，它分成3步骤。第一步，正常来讲，你先想办法去找出 delta。OK， 所以呢，对一雄大于0，我会找到一个 delta。对不起，在这个阶段我不知道它跟一雄有什么关系，但是我知道它有关系，只是我不知道它的关系是长什么样。所以这边我会是不是写 blah 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 一雄，也就是说，目前这一雄跟 delta 关系是 unknown，is unknown at this stage。然后我希望发生什么事情？发生说对任何 x， 它只要 s 减到 s0， 就是 s 减1的绝对值小于这个 delta 呢，我要想办法，我要证明它的 fs 减掉这 l，fs 这里就 5s 减3，l 这边是2，它要小这一雄，所以这个是我的目标，我目标做到这件事情。那这种证明通常是反着来，我的目标希望做到这样子，对不对？我最终希望得到这个结果，我就反着来，怎么反着来呢？从最后的结果来反推，怎么反推呢？好，既然你说这 fs 减掉 l， 你希望它的绝对值小于一雄呢，我就把 fs 写进来 5s 减3，我就把 l 写进来是2，所以 5s 减3减2的绝对值要小于一雄，对不对？我最后希望发生这件事情，对不对？好，这件事情发生，再整理一下，这个整理就不用我多讲了，对不对？然后继续整理到这样子，继续整理到这里的时候，你会发现 s 减1的绝对值会小于一雄除以5。bingo， 你会发现这里刚好是 s 减1，这边是 s 减1，小于 delta， 这边是小于1/5雄。对照一下，如果我让 delta 设定为一雄除以5，是不是就是我的一种可能的一雄，一种的 delta 了？所以呢，到这个结果呢，我就设 delta 等于1/5雄。然后呢，这是第2步，我已经找到答案了，对不对？注意哦，这个是一个 possible solution，one of possible solutions。我说过，你只要找到一个，不用找到那唯一的一个 ，OK？ 所以这第2步你找到，我可能让 delta 设定为一雄除以5，这件事情可能就会成立哦。好，我们再写一次，最后第3步，对这个一雄大于0，我可以找到一个 delta， 这个 delta 等于，就对比一下这个白色的，在这个阶段的时候 delta 我不知道它要写成什么一雄，对不对？在第3个阶段，我的 delta 已经锁定让它等于一雄除以5，对不对？对比一下这一行跟这一行是不一样的，在这一行的时候我还不知道 delta 要设成什么，在这一行我已经有一个候选人了，有一个候选答案了，我就是让它设为一雄除以5。然后呢，我们就开始写，再写一次 for 一雄大于0，我是不是可以找到一个 delta？ 好，这个 delta 我就令它为一雄除以5。当 s 减掉 s0， 也就 s 减1的绝对值小于 delta， 也就是1/5雄的时候呢，我要去看它最后会不会有这个结果。我要去看最后会不会这个结果。好，所以这个等于这个，那我就可以把它整理出来，变成 s 减掉1的绝对值小于1/5雄，整理出来，把5乘过去，再来把5乘进去，再来把 5s 减5把它拆成 5x 减3减掉2，它刚好就对应了 fs 减掉 l 的绝对值有小于一雄。所以大家再看看我红色的框框，对这个一雄大于0，我已经找到一个 delta 叫做1/5雄。 在这样一个前提之下，当我的 x 值呢跟 x0 的距离小于这个 delta 的时候呢，我的函数值跟 L 值会很接近，所以我就说它满足了 precise definition 的要求，所以我就证明了这件事情成立。好，下课之前我问大家一个问题，请问这个 delta， 假如我把它取成1/10 可不可以？那要不然我先留一个伏笔给大家哈，等一下下课的时候大家想一想，如果把这个 delta 取成1/10可不可以？又如果把这个1取成1/2可不可以？因为我刚刚讲过嘛，这 delta 不是唯一的，对不对？这是刚好这样子，你可以说它瞎猫碰到死耗子。但是我问大家一个问题，那既然它是 one of possible solutions， 我如果把它改大一点，改小一点，可以不可以？哦，这个问题留给大家，休息的时候有空的时候想一下。我们先休息一下啊。Of last hour, I just ask you if the delta I just pick delta as like, for example, how about delta is epsilon over 10 or delta is epsilon over 2? Which one can replace this solution? Which one? This one, right? This one is not okay. Not okay. Why? Because you can see, just take this figure as an example, that you can see if I pick delta 0.01 could be the possible solution for epsilon as 0.01. Then if I pick delta as 0.1 over 2, smaller one means if all points here can fall into this range, not to mention a smaller one. That means if delta 0.01 can make it satisfy, not to mention if I just divide it by 2, right? Smaller one, supposedly all of the points still fall into the range, right? However, if I pick another one, 2 delta, the range will become so large, become larger, right? But of course, I can make sure if x fall into this range, I still can make it fall into this range, right? But for the rest point, I cannot 100% make sure they can fall into the range. So that's why we always can pick, if we want to replace the answer, we can pick another one, but smaller one, not a larger one. Okay? So I hope you can understand that. So this, right now we already know this one is a possible solution. Then if you just opt for epsilon over 10, it's also possible. Could be the answer, could be the solution to this epsilon. But if larger one, that is not always true for this situation. Okay, so let me just, based on this idea, let me just give you a note that not a best one, not a best positive delta. Just one that will work. So as I say, you can just find one. It's more than enough. So you don't need to look for the best solution. You don't need to trying to find the best delta. If I can find one that will work, that will become workable, that is more than enough. Okay. So then in our textbook, we also try to teach you how to find a delta. Again, let me just emphasize, suppose a delta should be related to epsilon. But in the beginning, we just don't know what is the relation between delta and epsilon, right? For a given f of x, s0, L, and epsilon. So try to find one. So such that for any x, when s, the distance between s and s0 less than delta, I hope the distance between f of s and L could be less than epsilon. So that means if I give you a epsilon, then you always can return a delta. Then such that this relation hold. So let me just show you two steps. Step one is, please just solve this first. So-called solve this first means, did you remember button up? This is the final result. We expect that will happen. That will be happen. But based on this result, we're trying to trace back to see how can we just find the delta. So in the beginning, try to solve the inequality first by using this to find an open interval AB. By using this, right? Then containing S0 and on which the inequality holds for all x which is not equal to S0. So what is the inequality? The so-called inequality is this one. So this is step 2. It's step 1. What is step 2? Step 2 is find a value of delta that can place is S0 plus delta, S0 plus delta inside AB. So then we will get involved into 2 steps. Step 1 is, please just try to find the answer from the button, from the final result, from this inequality first. And then you can see here, based on this, you can try to expand it, right? For example, you can try to expand it into like this one. Then f of s is like this one. And eventually you can get s is, because s f of s here will be blah 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 x, right? But eventually you may, through some process, you can get s will sit in between blah 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 to blah blah blah, right? Then you can have a mapping that a will be this n, b will be this n. So this is the first step. The first step is try to, using this inequality to find the corresponding range for x. Then the second thing, you need to find a value of delta that place s0 minus delta, comma s0 plus delta. That means it's a symmetric at s0, right? So we can, so that means, for example, here you already know the range, right? So the range will be like this one, a and b. S0 is here, right? This is the first step. This is the first step. The second step, you need to try to find a delta to place this one into AB. So you need to try to find a delta. One delta is more than enough. Then using S0 as a center, then you can put like S0 minus delta to S0 plus delta. This interval can 100% fall into AB. So the delta could be like this one or this one. Another delta, but it still fall into here. So the second one, the second step is just get involved with finding the delta so that the whole interval from S0 minus delta to S0 plus delta can 100% be put inside AB.这边不好讲哈，不好懂哈，所以我除了这个英文讲一次，就中文也再讲一次，因为你刚刚听完，大家有一些似懂非懂的样子，但是这边我们还是要再很清楚让大家知道，第一步大家想一想哈，第一步也是从尾巴回来的，对不对？我们从尾巴推回来，还记不记得在这里的时候，我们是从这尾巴推回来的。事实上，在尾巴推回来的过程中，他在做什么事情呢？他事实上在做一件事情，做他 step 1的动作。好，我这件事情既然是成立，我希望从这边推出 x 的一些蛛丝马迹，可以找出 x 的范畴。你看，如果找出 x 的范畴，代表什么？这个不等式是成立的。也就是说，如果这个 f(s) 减掉 l 小的绝对值小 epsilon， 我去把它展开。对，像我这红色写的，我慢慢去把它展开出来，到最后呢，可能是 f(s) 介于什么 l 减 epsilon 跟 l 加 epsilon 之间。假如这 x 呢，又可以被整理到最后什么？它很干净，中间剩下 x， 那代表什么？我就找到两个边界点了，分别 a 跟 b， 对不对？那到最后就是什么？这 s 会落于 a 跟 b 之间，对不对？那 s 落于 a 跟 b 之间的意思什么呢？是这里的 x 永远可以让这不等式成立，同意吗？为什么？因为我这个 x 不就是从这里过来的吗？都是从这不等式过来的吗？所以如果我推到 x 介于某个 a 跟 b 之间的话，我可以确保这边的 x 的范围啊的点啊，都永远可以让这件事情成立。记不记得它的4元素里面最重要的就最后我要保证这件事情，要成立。 所以我就反着推它的 x 到底落在哪里。所以到第一步的时候，我可以先把 x 应该有的范围背上这个不等式呢去推出来。推出来之后Step 2是什么？要请你找出一个 delta 的值，使得什么 S0 减 delta 跟 S0 加 delta 要落在 AB 之间。为什么要落在 AB 之间？因为我有落在 AB 之间的时候，因为大家想，如果我有落在 AB 之间，那我就完成了两件事情了。第一个，我已经找到 delta 了，并且呢，以 S0 为中心，正负 delta 范围里面的 x 的值啊，我都会满足这不等式，因为这个是它最大的集合嘛。可是我现在找了一个 delta， 是它的 AB 的一个子集合。既然是子集合，代表什么 ？AB 如果可以满足的，这里面的点一定也可以满足这个不等式。对，我再讲一次哦。AB 是我们这样推出来的范畴，所以这个范畴的 x 值一定会让这不等式成立。那第二句话为什么想说要找出一个 delta， 使得这个 S0 减 delta S 加 delta 它要落在 AB 之间？它就要确保从 S0 为中心，你可不可以找到正负 delta 的范畴里面呢，让它完全落在这个区间。那落在这个区间里面有什么意涵？落在这个区间里面，我可以保证在这个区间的 x 点呢，这个不等式也会成立。所以那我们是不是就找出一个以 S0 为中心，正负 delta 范围的 x， 它永远会落到这个如来佛的手掌心，它永远逃不出去，它永远可以从这里，我一定可以找到一个范围的点呢，它一定这个范围的点的所有的点都会落到这个区间里面来。所以我再讲一次，从这个图来看，当我给你 L 的时候，当我知道 L， 然后当我也知道一雄的时候，我是不是框出来了？所以框出来，事实上我这边会对应出，如果对应这曲线返回来的话，我应该会对应一组范围，对不对？这组范围代表什么？如果我这边 L 减一雄，这 L 加一雄可以对应出这个范围的话，我要在以 S0 为中心的正负范围里面，要确保它都要落在这个区间里面，它才会依旧承继着它所有的点都会落到这个区间里面。反而不能超越，所以刚刚不是问你这个问题吗？是要比较大的可以，还是比较小的可以？比较小的可以，比较大的不敢保证。OK， 所以为什么他要找一个 delta 使得它要全部落在这里面？OK， so let's just using a example to impress you the concept. So please find delta algebraically for limit s is approaching 5, square root of s minus 1 is 2. Please find a delta, positive delta, that works for epsilon is 1. So you can notice this example is not asking us to find for all epsilon, but some specific epsilon, especially for epsilon is equal to 1. So that means if I give you epsilon is 1, can you just return a delta to me so that this relation still holds? Okay, so based on this, the solution here is step 1. We should try to solve square root of s minus 1 minus 2 is less than epsilon. Here is 1, right? Here is f of x. Here is L, right? But in this case, we just focus on epsilon is 1. On this condition, okay? So we just sub this to find an open interval containing S0. S0 here is 5, right? Okay, based on this, we can start to solve. It will be -1 less than square root of x minus 1 plus -2 less than +1. Then we can continue to get, we can get this one, right? This is -2, so we can add 2 as three parts. So here will become 1, here will become 3, and in the middle we can find it will just have square root of x minus 1 left. Then we can continue to get this one, so that finally we can get 2 less than 2 less than 10. So this till now we already find for the AB for the first step, right? Solve this to find an open interval AB. So in this case, what is A? What is B? What is A? 2. Yes. This is A. This is B. So AB here. So that means AB here will be 2, 10. Then for the step 2, what is step 2? For step 2, we need to find a delta. Find a positive delta. We can put it, we can place S0 minus delta, S0 plus delta inside the AB. That means 2, 10. So S0 here will be 5. This is 5. So therefore, we take delta S. Okay, let me just show you. This is 2. This is 10. And your delta, your S0 is 5 here. So 5 to the left end, the length is 3. To the right is 5. So can you tell me, should we take 3 or 5? 3, right? 3 is correct, right? Can we pick 5? No. Why? Because if 3, you can see for this end, no problem. For the right end, it's also no problem, right? If 3. But if 5, this end is no problem. This side is no problem. But for this side, big problem. Because except for this part, for this part, that possibly cannot make this equality satisfy. Because the original one should be 4 into 2 to 10. So in this case, we can pick, suppose we can pick minimum B minus S0 or S0 minus A. one of them. So that will be 3. That will be 3. Then based on this, when s minus 5, taking the absolute value of s minus 5 less than delta, delta should be this one, 3. Then we can make the absolute value of square root of s minus 1 minus 2 less than this epsilon. So finally, we need to pick this one, 3, not 5, because you can see this is 5, 5, 10, 2. So finally, it should be 3. So this is session 3. It's not that easy. I admit that it's not that easy. But only you just try to review the concept again and again, then you can suddenly feel, wow, it's really beautiful and also very interesting. So when I use the bracket, that means it's optional. This is optional. You can just try to see if you have time to have more practice. Otherwise, at least you need to practice, have some practice on these 3 questions. But for the rest ones, it's up to you. But even for this, even though it just seems like they are mandatory, but for you, it's still up to you, right? I cannot force you to have the practice. Only you can force yourself to spend some time on the practices.好，这一段真的不是很好懂了哈。不过我想说，很快的给大家那些观念的时候，请大家就是特别去注意，就是说，其实他也不断的在强调一件事情，就是说，像这种题目都是什么？从尾巴的范畴去反推它的 x。所以第一步呢，其实他也是这样做的。你要找一个这样的一个，给你一个一雄的时候，要找出一个 delta 的时候呢，它其实也是从尾巴开始做。做到最后解出一个 AB 的范围之后呢，再由第二步里面呢，我要找出一个 delta， 这个世界的 delta 不一定只有答案一个，那最多呢，以这个例子来讲呢，就是说你最多可以找出他们两边这个点到两边最短的那一个，再更小可以不可以？比方说这是3跟5，对不对？我当然不能挑5了5不行，因为5呢。以这个例子来讲了5当然不行，5会满足了这边，可是这边不会满足。可是3呢，它可以这边满足，这边也满足，所以3是 OK 的。那请问它2可以不可以？可以的哦，2是可以的，1也可以， 0.5 也可以。为什么？只要比这个最大的这个3来的小的都可以。为什么？因为只要比它小，你的范围都还在这里。如果你的范围都还在这个红色范围，代表什么？你的不等式还是这个范畴还是可以成立的。你这个不等式的范围，你这不等式的范围还是成立的。所以为什么我们会永远从尾巴去解出它的这个 S 的范畴，就是这样来的。那这部分确实不好懂所以我想说，回去以后大家真的要花一点时间去理解它Okay, so if you don't have any questions, let's just move to one side limit. one-sided. So in the past, when we just say limit x is approaching c, f of x is equal to L, we are talking about two-sided limit. One is from the left-hand side, one is from the right-hand side, right? So, but sometimes, if f of x fails to have a two-sided limit at c, but it may possibly still have a one-sided limit. One like right hand limit, like limit s is approaching c plus. C plus means a little bit more than c. Okay, so also c plus means the right hand side of c, right hand side. Okay, so this possibly just like this one, or left hand limit. The hand limit will be expressed as s minus c minus f of s is L. Two possibility. So, like, for example, f of s is equal to x over absolute value of x. So what is the figure? What is the figure? For x is so for x is larger than 0. If x larger than 0, what is the result? 1, correct. Will be 1 because its domain will not include 0, right? For x is less than 0, what's the result? -1, yes, correct. So we can see limit s is upon 0, f of x does not exist. Why? Why does not exist? Because from the right hand side, the answer should be 1. From the right hand side, the answer should be -1. This is +1, this is -1. So different. Because if we say two-side limit, that means either from the right hand side or from the left hand side, these two limits should be the same, right? But in this case, you can see at this point, if you try to get the limit from both sides, they cannot have the same one. From the right hand side, the answer should be +1. For the left hand side, it should be -1. So +1 and -1 are different. But actually, we still have like limit s is approaching 1 plus 0 plus. What is the result? 1, right? It should be 1, right? Because from 0 plus, 0 is here. From 0 plus, that means from the side where whose value is a little bit more than 1 and then 0, right? So the result will be 1. And we also have limit s is approaching 0 minus f of s. The answer will be -1. Right? So even though you can see in this case, even though we don't have a two-sided limit for s is approaching 0, but we still have two one-sided limits. But these two one-sided are different. What for one side is 1, for the other side is -1. So then we can conclude a theorem. If we have two-sided limit at s is equal to c, then if and only if limit and limit s is open c plus f of s should be the same one, L. So what is the symbol? Its meaning? If and only if. If and only if means from this side we can conclude this side. From this side we can conclude this side. So that's why we can have a if and only if condition. Right? So I can give you a very quick example. Maybe it's a very simple example. 1, 2. Sorry. 1, 2, 3, 4. If I have a function, its curves are like this one. This y is equal to fs. So when I ask you limit s is approaching 1 f of s, does it exist? Does it exist? No. Why? Because you can see we focus on s is approaching 1. So 1 is here, right? So from its right hand side, suppose the answer should be 1. But from its left hand side, it will be 0, right? So this doesn't exist. Why? Because limit s is approaching 1 plus f of s, it should be 1. But limit s is approaching 1 minus f of s, it should be 0. So 1 is different from 0. Because if you want to have a double or two-sided limits, you should have two one-side limits. And also these two one-side limits should be the same. Here is L, here is also L. Then your two-sided limit will be L. And for example, okay, let me this is the first equation. Then this is 1, the second one. How about limit s is approaching 2 f of x? What is the answer? Does it exist? Does it exist? Yes, because you can see limit s is approaching 2 minus f of x, it will be 1. For limit s is approaching 2 minus f of x, it is still 1, right? So we can conclude s is approaching 2 f of x is 1. even though f of 2 is how much? 2. Its function value is 2 here, right? So you can see the limit value, the value for its limit is not necessarily always the same as its function value, right? Just like I say. But if these two ones are the same, then we will say it is continuous. Okay? It is continuous. But at this moment, based on this function, you can see, okay, we can conclude that there is a two-sided limit for this point, but its function value is 2. They are different. But we still have the two-sided limit for this part, even though they are different. But if they are different, we will say it's discontinuous. But if they match, they are the same, then we will say it is continuous at this point. Okay, so let's just stop here. And later, I'm not going, due to the time constraint, this time I may not give you any example. However, okay, so let's just look at what is the precise definition for the one-sided limit. So here we just focus on one-sided instead of two-sided. So if we focus on two-sided, you can just trace back here for this one. For any given epsilon, we always can find a delta corresponding to this epsilon. Then for any x, when the distance between x and x0 is less than delta, then we always can conclude that the distance between fs and L could be less than epsilon. So this is for double-sided. So we can slightly adjust this one to get the precise definition for one-sided limit. So, for example, when we just define what is limit s is approaching s0 plus f of s is equal to L. So plus means from the right hand side. Okay, so the definition here is also for any epsilon. We always can find a delta, so it's quite similar, right? Such that for all x, if s is between s0 to s0 plus delta, then we always can get the distance between f of s and L could less than epsilon. So you can just have a simple comparison here. This is for the one-sided limit, right? So you can see, compared to the two-sided, the range will be x is larger than s0 minus delta to s0 plus delta. So you can see this is for two-sided. So two-sided means s0 is here, then s0 minus delta to s0 plus delta. And we just pay attention to this point, right? We just pay attention to this point. So this is for two-sided. because you can see we not only care about the right hand side, we also care about the left hand side. But here, since we just pay attention to x is approaching s0 plus. Plus means the right hand side. So you can see the x range is, of course, for just focus on S0 to S0 plus delta. So here, I also can draw you that we just focus on S0 is here. We just focus on here to here. We just focus on this part. We don't care about this part. This part we don't care because we just focus on the right hand side. So you can follow this way. If we want to define limit s is approaching S0 minus f of x is L. So I think right now you can try to guess that for any epsilon, I always can find a corresponding delta such that for any x, the s should be, what is the range? Should be from S0 minus delta to x0, right? Then we always can have the distance between f of x and L should be less than epsilon. So here, this time we just focus on this part. So then this part we just focus on here, right? Compared to the S0 plus, we focus on this part. If we focus on S0 minus, we will focus on this part. If we focus on double-sided limit, we will pay attention to both sides. Okay, so it's quite easy. It's quite easy to extend the idea for the precise definition of a limit to a two-sided limit to a one-sided limit, right? So right now we already have three precise definitions for the limit. One is for two-sided. One is for two one-sided limits. So again and again, I believe you will get used to the definition, the precise definition for the limit. So due to the time constraint, this time I will not give you example, but I also show you a theorem 7 for limit theta is open 0, sine theta over theta will be 1. So you can find this function is very interesting. You know, for sine function, y is sine theta. You can expect the curve for the sine theta should be like this one, right? This is for the sine theta. But if we focus on y is equal to sine theta over theta, the curve will just look like this one. We will like this one. This is for sine theta over theta, and the range is its domain will be from negative infinity to positive infinity, but exclude 0. That means 0 cannot be counted in the domain of this function. So please just make a comparison in between. So let me just show you how to prove it. After I prove it, please just keep this in your mind. In the later session, I will show you how to using this result to calculate some limits. So before that, I will show you how to prove it. So if you want to prove it, let me just show you the unit circle, especially for the first quadrant. This is the first quadrant. So this is a unit circle. The so-called unit circle is, this is the center 0, 0, and the distance is 1. The radius is 1. Of course, we can just extend it. This is a unit circle, right? But if you want to prove it, so let me just denote some key points here. For example, this is A, and this is, if I just emit one ray from 0, 0, then the intersection here is P. Okay, and then if I make a right triangle here, if I say this point is T, then we already know it's a unit circle, right? So the distance here, because it's radius, right? So the length here will be 1. So I will make 3 triangles here for your reference. The first one is this one. This is a right triangle. And this is another triangle. But I just make a height here. And if we say the angle here is theta, so based on the triangle, we can get that the height is sine theta, right? If I want to calculate the green triangle, I need to know its height, right? So then I just get the height first. It will be sine theta. But for this one, for the white part here, you can see it's a fan. It's a sector. Fan sector. It's a fan sector. And the yellow part is another triangle. So, and we also need to know its height. Its height here is tangent theta, right? Because this is 1, this is the theta, so that the height AT should be tangent theta. So based on this, we can get that triangle, if the center point we denote it as O, then the triangle OAP should be less than and equal the fan sector OAP. Then this part will less than and equal to triangle OTA or OAT, right? So we can see this one is the largest one. The yellow one is the largest one. Then the smallest one should be this triangle, green one. So in between, we have a fan sector here. So you can see just that sandwich theorem, right? This is the largest one, this is the smallest one, and in between we have the fan sector here, right? So then we start to calculate the area. OAP will be 1/2 times its base times its height. Then this is a factor. This is a fan sector. So the area will be 1/2 times radius squared times theta. Then the largest one is the yellow part. It will be 1/2 times base is 1, then tangent theta. Right? So please just take a look at this shape, then also make its area for each part, then you can get this one. So after some simplification process, we can get sine theta less than theta, then less than tangent theta. But sometimes, because we want to prove it, right? So we can just divide it into two parts. Limit theta is approaching 0 plus sine theta over theta. Then also try to calculate limit theta is approaching 0 minus sine theta over theta. So we try to calculate these two ones. Then if these two limits are the same, did you still remember 2 hours ago we just learned this? If here you can see if limit s is approaching c minus f of s is L, and also for limit x is approaching c plus f of s is also L, same L here, we can conclude its two-sided limits is also L, right? So here, if we want to prove this is a two-sided limit, can we just divide it into two parts? One is for 0 plus, one is for 0 minus, right? So in the past, maybe based on this one, we may write down just like this. But if equal, that means the theta should be 0. So at this moment, since it's approaching 0 plus means theta will not touch 0. Always touch the number which is a little bit larger than 0. So we will not consider this case if theta is positive. Okay, so normally we don't think about that. If equal, that means the theta is equal to 0. So it's a very special case. But of course, if we want to use the sandwich theorem, it still works. So right now we can get the result just like this. So right now we just focus on theta is approaching 0 plus. So then we have this result. Then we can continue to simplify it by since theta is larger than 0 but less than 1/2 pi. So sine theta could be a positive number. So based on this, since it's a positive number, so we can divide it sine theta, then sine theta, and also sine theta, so that we can get 1 less than theta over sine theta, then less than 1 over cosine theta, right? Because it is positive, so we can just divide this a positive number, still keep the relationship for this way, this direction, right? then we can have 1 less theta over sine theta less than 1 over cosine theta. Then we can upside down. Upside down means 1 larger than sine theta over theta, larger than cosine theta. Right? So as theta is approaching 0 plus, cosine theta is approaching 1. So again, if the theta is approaching 0 plus, then 1 still approaching 1, right? So based on the sandwich theorem, we can get limit sine theta over theta. When theta is approaching 0 plus, it will be 1. Because here is 1, here is also 1. So in between, sine theta over theta also will approach 1. Right? So this is for one direction. So you can see here, we already can get this one. So we already, based on this is the first step, this is the second step. So right now we already have the answer for this part. This should be 1. Right? This should be 1. After we prove it here, right? We already know this part is 1. So supposedly we need to do it again for this part. Supposedly. But actually we don't need to do that. Why? Because, you know, right now, since y is equal to sine theta, is a r function or even function. Did you remember? Sine theta is a r function or even function? Odd function, right? It's an odd function. Did you still remember what's the r function? R function means if I use minus s as an input, we can get minus f of x back. Right? This is r function. And y is equal to theta. Can you tell me this is an r function or even function? Odd or even? Y is equal to theta is odd or even? Huh? Odd. Also odd, right? Also odd function, right? So when we just divide it together, y is equal to sine theta over theta will become an r function or even function? Even function. Why? Because, you know, if this can come out one negative sign here, this one also will contribute one negative sign here, so they can cancel that together. So then it will be an even function. So what is the even function? Even function means when I use minus x as the input for the function, then I can get f of x back. Now this is an even function. So since it's an even function, did you still remember if it's an even function, the function's curve will be symmetric about the y-axis? Did you remember that? Right? So that if it's symmetric, so this one will symmetric about the y-axis. So based on this fact, we can get limit theta is approaching 0 net. minus is also 1 because it's symmetric about the y-axis. So we have this one, we also have this one. So right now we already have this one. This is also 1. So 1 is equal to this one. So for the both side, we can have one-sided limit, and also their limits are the same. So based on this, 1, 2, 1 plus 2, we can conclude sine theta. When we just calculate the limit, sine theta over theta, when theta is approaching 0, it will be 1. Actually, the figure is just like this one. For sine theta, it's a periodical function, so you can see it always just the value will travel back and forth between positive 1 to negative 1, right? But for sine theta over theta, that will be different. As theta is become big, the value of the theta value is become bigger and bigger, you can find finally, since sine theta always has a return value from +1 to -1. So, but theta is continuously increasing, so you can finally see the value will be very close to 0. But for this certain point, it should be, even though this point 0 is not included in the domain of this function. However, we still can get its limit. So this is the proof for this part. But if you don't have time, at least build something in your mind. If you want to prove this, we try to get its two one-sided limits and see if they are the same. So we try to use this one to prove one of n, then use the property of even function, then we can get the other one. Then finally we say limit theta is approaching 0, sine theta over theta is 1. Okay, so let me just give you an example how to use this fact. If we want to calculate this, what is the result? What is the result? Okay, when you just see this one, you cannot, okay, I just demonstrate a wrong process. Okay, so you can see here, based on sine theta, limit theta is approaching 0, sine theta over theta. Okay, here is 0, here is 0, so the result is 1. So can I conclude that, oh, okay, this one is as s is approaching 0, 2s is approaching 0, 5s also approaching 0, so the result is 1. It's wrong. It's wrong. Yes, yes, we need to adjust. We need to adjust that. Yes, 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 yes. So hey, this is why I want to impress you. So I just show you a wrong derivative. So the correct one should be like this way. The correct one should be like this way. Limit s is approaching 0, sine 2x, right? But 2x, you need to have a 2x here. Because these two ones should have the same pace, have the same speed. So here 2x, you need to make then to have the same speed. So it should be 2x. However, this is 5x. So supposedly we need to times 5 over 2x. Sorry, here here, right? After I just resequence the number, you can see 5x, I just converted from 5x to 2x times 5 over 2. So that will come back to 5x, right? But the difference is, since it is a constant, we can move it outside, become 2 over 5, then limit s is open 0, sine 2x over 2x. So, and then you can see, if we just replace here, s is open 0, so that means 2x also replace is approaching 0. Then if we just let theta is equal to 2x, then you can see here will become theta. Here will also become theta. So that right now you can have, limit theta is upon 0, sine theta over theta, right? We already know the result is 1, right? Then finally we can get a result 2 over 5. This is the correct answer. This is correct. This is the wrong one. This is the wrong one, because you know here is 2x. This is 5x. The coefficients are different. So we need to convert it to become the same one. Just like this one. 2x, if sine 2x, we should have a 2x. But since this is a 5, originally it is 5x, so we need to convert it into 2x times 5 over 2. Now we can get the result is just like this one. So finally, this is the correct answer should be 2 over 5. 2 over 5. Okay, so this is for section 4. This is for section 4. So again, I give you some questions for your reference. So is that okay? So at this moment, what you need to memorize in your mind is this one. Is this one. Okay, so let's just move to section 5, continuity. So what is continuity? So last time we just talked about this one, right? I just use this as an example that what is continuity. So based on this figure, you can see that for this point, even though we have two one-sided limits, from this side we can get the limit is 1. From this side we also can get the limit is 1. But based on these two facts, we can get its two-sided limit is 1. However, the function defined here is 2. So we cannot say it's continuous. It is continuous. But you can also take a look at this point. When x0 is 3, you can see from this side, from the right hand side, you can see the limit is 2. From the left hand side, the limit is also 2. So we can say limit. So we can say limit s is approaching 3. F of s here should be 2. But luckily, you can see the function value is also 2. So its function value is the same as the two-sided limits. Then we will say it's continuous. You can see here to here, no any broken point. But from here to here, the value starting jump to here, to be here. then suddenly go back to here, to be here, then we will say this point is a discontinuous point. Okay, so use this one, we can have an understanding about this continuity. So based on this idea, we will define what is continuous at a point. So let's just focus on continuous at a point, then we can gradually define if for some certain interval, if the function is continuous. And then finally we can define what is a continuous function. So let's just start by continuous at a point first. So for this part, we also divide it into two types. One is the interior point. What is the interior point? Like, for example, this is an interval, or this interval, or this interval. The so-called interior point should be here. Interior point should be here, inside the interval. So interior point, for interior point, f is continuous at an interior point C if limit s is approaching C, f of s is equal to f of C. Based on this expression, there are three meanings. The first one is, if you can write down limit s is approaching C, f of s, that means we can have a two-sided limit. We can have a two-sided limit. If we can write down f of c, that means this function f of s is defined at s is equal to c. But as I showed you in the previous case, this is not always equal to this one. The only condition is if at this point it is continuous. Okay? So it is not always this. These two values are the same. Only when the point is continuous. So if we focus on interior point, I mean inside, right? Inside the period. So you can see for inside point, we need to take care about, we need to pay attention to its right hand side. We also need to take care about its left hand side. Then see if these two limits are the same. Then we will conclude if the two-sided limits exist. And besides, we also need to focus on if the function is defined at x is equal to c. If these two numbers are the same, then we will say it is continuous. Okay, this is the for interior point. And for endpoint, what's the endpoint? Endpoint means here. This is endpoint. This is closed interval. This is open interval. This is semi-closed interval, right? So the endpoint, I mean for these two points, for these 2 points, for these 2 points, for these 2 points, this is an endpoint. If for endpoint, if we want to define it is continuous at a left end point or at a right end. What is left end? Left end means the interval. For left end means this point. Right end means this point. If we focus on this part, then you can see, taking the left end point as an example, you can see we just focus on this part. We will not pay attention to its left hand side. So we only focus on this part. So for the, if it's left-hand end, then we will say if limit s is approaching, if this is A and this is B, limit x is approaching A plus f of s should be the same of f of A. So you can see, we just focus on its right-hand side. So of course, we just pay attention to limit x is approaching A plus. A plus means a little more than A, not A itself. So if limit x is approaching A plus, f of s it will be f of A, then we will say it's continuous at its left end. So, or limit s is approaching B minus f of s, it will be f of B. Okay, so I'm afraid we need to stop here, and next week I will continue to introduce the discontinuity to you, but at this moment we just focus on the continuity first. Okay, see you next week.